This video will teach you about 3.7, 8, and 4. First thing from 3.7, we have the determinant. The determinant is a value that every square matrix has. If it is equal to 0, then there is no inverse matrix. If it is not equal to 0, then the matrix has an inverse. When we are looking for determinants, we're looking to see if the matrix does have an inverse, which means we can use it to solve on our calculator. If it doesn't have an inverse, then we need to solve these systems by a different way. When you have matrix A with a 2 by 2 square matrix, elements A, B, C, D, the determinant of A is found by taking your diagonals and multiplying them, so A times D and B times C, and subtracting the 2. BC is second. So with this example here of 3, 7, 5, 8, we take 3 times 8 minus 5 times 7, or 7 times 5, does not matter the order. 24 minus 35, you get negative 11. When you do a determinant of a 2 by 2, you'll do that by hand. If you have to do 3 by 3 or larger for a square matrix, you will have to use your calculator. On your calculator, if you would like to check it, you can always check it in matrix. If you go over to math, the determinant is right there. So you would do determinant and then go matrix, and you can check it, but I will tell you this, if you don't show your work by hand for a 2 by 2, you will not get credit. Solving matrices. Matrices, when you're solving, you need to have the determinant to find the inverse. When you are doing that, you're going to have the identity matrix. A matrix when multiplied by or to another matrix doesn't change, it keeps the identity. The diagonals are 1, so a 2 by 2 would be 1 1s, the other thing zeros. 3 1s down the diagonal from the upper left to the bottom right. 4. So what we're going to do is we're going to prove that the identity times this matrix here is equal to itself. So row times column, so 1 times 5 plus 0 times 3. This one is going to be 1 times 4 plus 0 times 2. This one will be 0 times 5 plus 1 times 3. And this element down here, row 2, 0 times 4 plus 1 times 2. Simplify this out. This is 5, 4, 3, 2. Still going with 3.8. So what we're going to do is we're going to see if two matrices are inverses, which means their product is going to be the identity matrix, because we will use those to solve. So when I multiply this, it's going to be 3 times 1, so 3 times 1 plus negative 2 times 1. 3 times 2 plus negative 2 times 3. Negative 1 times 1 plus 1 times 1. Negative 1 times 2 plus 1 times 3. So 3 minus 2 gives me 1, 0, because that's 6 and negative 6. Negative 1 and 1 gives me 0. Negative 2 and a positive 3 gives me 1. So these are inverses of each other. Make sure that when you check if they're inverses of each other, you must multiply on both sides. So you would have to multiply on this side and then also do the other side. So find the inverse of a matrix, 2 by 2. That means we're going to take a matrix to the inverse. And this is another way of writing it by hand. When the matrix A is defined by A, B, C, D. So in order to find the inverse, this is the inverse. The calculator is really cool and can do this for us, but if we ask you to do it of a 2 by 2, you must do it by hand. So what you do is you take the original matrix, you switch your A and your D, and then you change the signs of your B and C. So you switch the first diagonal, and then you just change the signs. And then the determinant, if you don't recall from just a little bit ago, is AD minus BC. So we're going to find this inverse by hand. So first, 1 divided by diagonals. So I'd have negative 1 times negative 2 minus 0 times 8 which gives me 1 over negative 1 times negative 2, which gives me 2 minus 0, so 1/2, okay? This determinant here, so what we would do is this is 1/2 simplified. We switch our diagonal, so we switch these two. So this becomes negative 2, and this becomes negative 1, and we change the signs of this diagonal of B and C. 0 stays the same, and this becomes a negative 8. And what you should do is after you have this, you should multiply it through, because this is now scalar multiplication, so you should have negative 1, 0, negative 4, and a negative 1/2. That would be what your true determinant is. Now, on our calculator, so we're going to check on our calculator, typing it in. We're going to go second x to the negative 1 for matrix, unless you have a matrix button on the right here. There might be a matrix button right here. Second, x inverse. We're going to edit the first one. It's a 2 by 2, so negative 1. Oops, let me try that again. 2. Negative 1. 0, 8, negative 2. Alright, now that I have that, I'm going to go second quit. So what I'm going to do is I'm actually going to hit second matrix. I'm going to call up A, and then this inverse button is your best friend. That means it's going to find the inverse of that, and there's our answers, which match. So negative 1, 0, negative 4, negative 0.5. Okay, and I can always do this and make my answers into fractions if I want them to be in fractions. So that's how you do it by hand. So when do we do that? We're going to use it when we solve systems. So this is 3, 4, and 3, 8. 3, 4 is usually in 3 variables. 3, 8 is usually with 2 or 3. So the way it works out is your systems need to be written in standard form, ABC order. And what we do is we take the coefficients of x and y. That makes its own matrix. Your variables go here. That's denoted by a variable x. Matrix. It's not used in your calculator, but we need to have it. And your constants go in B. So this would be 1, 2, 3, negative 6. Your variables are x and y, and if you multiplied this by hand, you would get this product, because it's row 1 times column 1, so 1 times x, 2 times y. And then your constants are 9 and 3, which means they're your solutions. So what we do is we set this up first. You must write this first if you want to solve by matrices. Then you write this. Then you write this. And what this does is when you take the inverse and you're solving, in order to zero this out, meaning the identity matrix, we need to have the inverse on both sides. So what we're really doing is we're going a to negative 1, or a to the inverse x, equals a inverse 1 of b. And if you do this by hand, we could, I'm going to save you the time, this becomes the identity, which means this matrix will never change. So when I multiply it out, I would keep that. This here, if I multiply on the left here to do the inverse, I also have to multiply the left over here on the constant matrix. So when you solve it, this is how we do it. Okay? Then what you get to do is type in your calculator, get your answers, and then you must write it as a point. If you solve these and you get a error, like a no solution or a singular matrix, then you must use a different method. So what I'm going to do is I'm going to walk through this really quick, and we're going to show it through. So second matrix, edit, 1. So it's a 2 by 2. So I'm going to take my constants that I just had. So I have 1, 2, 3, negative 6. Second, quit. Second matrix, edit, 2. Pardon, my lights are going off here. And that's going to be a 9, 3. 9, 3. Second, quit. So what I do is I hit second matrix 1, inverse, second matrix 2, enter, and that's my answer. Didn't have to solve by substitution, did not have to solve by graphing, did not have to do elimination. I could have, if I wanted to. And if we had a little bit more time today, I would totally walk you through that. So that means 5, 2. And so then my answer is a point. You got to write your answer as a point. It's not just written as a matrix. Like, you need to write it as a point as well. So with that, please let the lights readjust here for a second. There we go. So we have some different problems. This one here, if you were to solve it, you would have 3x minus y equals 4, x minus 2, plus 2y, because I want to move that y over, equals 0. So your coefficient matrix that you would set up, 3, negative 1, 1, 2, times x and y equals 4, 0. So the work would be a, x, b, x equals a to the negative 1, b, xy equals whatever answer you get, which then you write as a point. This matrix here, negative 1, 4, negative 1, 3, 3x, or so x, y, that's a z. I'm assuming that's a z. Let me double check. That might be a z or a 2. I'm not too sure on that one. I'm assuming it's supposed to be a z, so we're going to add a z in here. So let's go 3, 2, minus 2, 1, 3, negative 5. So that's 3 variables. So now that we have 3 variables, we got x, y, and z equals negative 9, 3, 29. Okay, this is a, x, b. X equals a inverse b. xy equals an answer, and then that would be written as a point with 3 parts. Okay, this last one I really want to talk about here. You have missing parts. You're missing an x, you're missing a y, you're missing a z, and every part has to be accounted for in your matrix. So coefficients here, so the first one, coefficient matrix would be a 1, negative 1, 2. I have an x, so that's a 3. I have a z, that's a 1, but since I have no y, I have to put a 0 placeholder there. You have to put something there, and it doesn't just magically get to go wherever you want it to be. It has to be with the corresponding variable. Negative 1, 2, and 0. X, y, z equals 0, 11, 0. So remember, if you have missing variables, you have to use placeholders.